Hey there, YouTube. This is Raining Cryptos here. Today we're going to go over the blockchain, which is with the distributed blockchain, and all the subcomponents of that, which is the backbone infrastructure for the Bitcoin and other cryptocurrencies out there. That primarily use this blockchain technology. So I'm leveraging a website here at blockchain.mit.edu. This was created by Anders Brownworth. I want to give all the credit to him. So I just wanted to share that with everyone today. All right, so let's get into it. So the first thing is we have the hash here itself. So inside this data field here, if I type anything, so this hash is for no information, but if I say like hello world, this hash is going to change, and it's capturing this information here, return key, goodbye, or whatnot. All of those have a referenced hash, and that's all in capturing the information in this field, and you could fill it up with as much information as you want. So we're going to eventually connect this to how things work on Bitcoin or tokenized type technologies. So the next thing we have here is the block. Okay, so here you have a block number. And then you have this thing called the nonce. We're gonna get back to the nonce in a second. So right now you have a blank data field that takes this nonce number in the block number into consideration. So again, we'll type some information here in formation here, and as you can see here, everything went pink. Now, if we go back to the zero condition, or the blank condition, you can see here we have a header, and this particular block prefers to have the header, an acceptable header, beginning with 4 zeros. But when you enter information or anything else into the data field, the hash changes. So people ask the question all the time, what is mining? What is the function of mining? So the function of the mining here is to put the hash in a particular format. And in this particular case here, the web interface that's been set up by Anders Brownworth, it's giving you a header of 4 zeros. So it's going to keep the data field and the block constant, and it's going to calculate a nonce such that the hash has 4 zeros here in the header. So if I click the mine button, and again in Bitcoin, the miners in Bitcoin and other currencies that use a technology called proof of stake, proof of work. I'm sorry, proof of stake is another technology. They use a technology called proof of work. They get rewarded when blocks are created for actually performing these calculations. So they get rewarded for exercising processing or some type of computer power. A lot of cases, for Bitcoin, it's typically today mostly ASIC processors. Other coins and tokens out there also leverage GPU-based NVIDIA-rated type of processors. Anyway, so they receive the block information, and they perform a mining function, and they get rewarded with coins, and those coins are then attributed some type of value in the marketplace. So when you click the mine function here, it's taking a minute. There you go. It's now the nonce has changed, and this is an acceptable block for the data in this particular field. Now, if I go back here and I delete this, it changed the header. Now, if I go back, put it in place, it now has the proper header and it's an acceptable block. So, okay. So we've gone over a hash. We've gone over the changes in the data field, how they affect the hash, and we've also gone over mining. It's pretty cool. Moving our way up. We've got the blockchain. So these are the chains now of blocks. Okay. So what you see here is this would be the Genesis block, or the first block in the blockchain. There is no previous block to connect to this, but in the blockchain, the hashes are interconnected from one block to another. So the previous hash from block 1 is in block 2, and so on. This makes the blockchain mutable. So this gives you that level of confidence and security of the history of, or really the blockchain is at the end of the day, which is a secure ledger type of database of all of information or data. And in the case of the monetary type of coins like Bitcoin, it's a ledger of financial transactions. So if I go back here and I change the information in this particular block, it affects what goes on in block 5, because these two were linked. So the information from this block went over to that block. Now, if I were to change the information in this block alone, and then I mined, as you can see here, once this is completed, the nonce will change to accept the new information in that field. Now, if I go back to block 3, for example, and I make a change over here, it's had a cascading effect down to blocks 4 and block 5. So I'm going to have to remine block 3, block 4, and block 5 for this to be an acceptable blockchain. Okie dokie. All right, now we're going to move to distributed to blockchains. Now, this is how Bitcoin operates. So what you have here is, if you think about it, this is a copy of the blockchain shared amongst the miners, all the mining processing power, all globally throughout the world. In the case of Bitcoin, so all these miners are receiving these new blocks, and they're all trying to be the first to process this information and get rewarded with the Bitcoin. And you know, whenever these blocks are created in Bitcoin, currently it's every 10 minutes. Others have different levels of frequency and different algorithms, mathematical algorithms for difficulty and whatnot. So this proof of work algorithm gets in this distributed ledger, gets sent all throughout all these miners, and there's a democracy that occurs. So if for some reason we get down, let's just get down to the last block. I think we can get 3 peers here, or three. Let's consider 3 copies of this particular blockchain. So, for example, if peer B says, for example, the data I have in my field here is called red, it's going to be in disagreement with these other 2. So if by democracy, this will get voided out. So no one can come in here and falsify this particular record or past records. So if we go back to this field here, and I say, green, these historical blocks get nullified from a democratic vote, because the majority of these other ledgers are saying these entries are invalid. Okay, so that's the power of the distributed blockchain. It's not one ledger. It's millions of these instances of ledger distributed worldwide, and that's really the power and the magic, if you want to call it, or the secret sauce behind the Bitcoin technology. It's truly a democratic type of protocol that works globally. Okay, so now we've worked our way up to distributed blockchain. Let's talk about tokens and tokenization. All right, so at the end of the day, everything within the ledger, as we were going before, and we really don't need to get into a lot of detail here, but everything at the end of the day is transfer of value from one person to another. So if let's just go down to the last block here. So we have three blocks. I apologize if you're getting dizzy scrolling up and down. But so if we start here, you could say I'm going to send $1 or whatever amount of value here from one person to another, and again, this information will get will get verified and distributed amongst all these different copies of the ledger. All right, so you have different values, different instances of values that could occur, and they can be sent from one address in Bitcoin's case and of value to another address. So I just wanted this to be and I want to thank again Anders Brownworth for putting to this this really nice visual view and overview of the functionality of how a blockchain works. I really want to thank him. It really helped me a lot when I was getting early on investigating into blockchain technology and trying to educate people on how it works, and sometimes seeing it in a visual and functional way is extremely helpful. So again, thank you. Please share, like, and subscribe. And again, this is the above that has been shared is for educational purposes only. I'm not a financial expert, or please see a financial advisor for buying, purchasing, or advice with cryptocurrencies. Thanks again, and we look forward to talking and seeing you at the next educational video. Take care.